Breaking news, brought to you by the Coral News channel. Viewers from all over the sea, there's an urgent coral crisis. Corals are dying. Coral reefs, these vital and vibrant ecosystems, are dying at an alarming rate due to climate change, pollution, coral bleaching, and diseases. Even though these ecosystems only cover under 1% of the ocean floor, they house over 25% of the marine life. Moreover, these underwater worlds support over 500 million people worldwide. That's more than the population of the whole South America. This crisis can possibly affect you, or even you. But a little hope has been discovered in recent studies. Probiotics restore coral health, strengthen corals, and cure coral diseases. The current delivery mechanism includes using plastic wrappings to increase probiotic retention and antibiotics that provides a rapid response to disease outbreak. However, even though of having the intention of saving coral reefs, these approaches are causing severe environmental issues and resistance to corals. If we don't find an effective and sustainable solution to this pressing problem soon, the citizens of both the sea and the land will find themselves in great danger. This is Leah reporting this urgent news. Thank you and stay safe.
Coral reefs are an important aspect to not just one species, but the entire ecosystem. I wonder if there's any ways to help the corals. QREs, how can I help you? Did you say probiotics? Sure thing, we got lots of them in stock. Where should it be delivered to? Under the sea? For sure, I'll see you soon. Wait, under the sea? Research and development, emergency. A client has just asked me to deliver probiotics deep under the sea. Can you help me formulate a plan to deliver this? Please. Okay, bye.
What? Deanna.
What?
Control has requested us to make a coral probiotic delivery system under the sea. This is such an impossible task.
Let's not panic yet. I think the first problem we need to get around is to get the probiotic down into the ocean without the package falling apart. So the package must not harm the environment and will not float along with the ocean current.
Oh, I have just the idea. Do you remember how Dr. Tang Xinling, a leading microbial ecology expert in the development of coral probiotics, once said that corals are made up of a community of individual coral polyps?
Yeah, I remember.
These polyps are covered in a layer of mucus that they use to protect themselves. But this mucus also serves the purpose of helping the coral capture microorganisms for the coral to consume. One of the main species of bacteria that corals consume is SAR11. How about we target the coral's mucus mechanism and engineer SAR11 to produce biofilm and then spray it together with the probiotic? Because biofilm provides a habitable environment for bacteria, it lets both species of bacteria attach to it and then to the coral mucus. After that, the probiotic will be able to enter the coral when it tries to consume the engineered bacteria.
Oh yeah, that's right. We synthesized the CSG gene from the MG1655 strain of E. coli, which is responsible for biofilm production. Through the implementation of the T7 promoter, we were able to attain high levels of biofilm production rate.
That sounds good, but won't there be excess biofilm production?
That's true. So that's what our biofilm regulation mechanism is for. Biofilm production in bacteria is regulated by quorum sensing with low population density leading to high production rates. As the population increases, biofilm production is repressed through MedJ protein action. A SINR-SIN-I-SIN-S system further regulates MedJ synthesis and AHL production based on changes in population density. There are concerns about genetically engineered bacteria escaping into the ocean from coral reefs and potential ecological consequences. But what if some of our bacteria get away from the coral?
We have a solution for that too. Our biosafety mechanism utilizes a toxin-antitoxin mechanism also based on quorum sensing. When the bacteria floats away, the population density will become very low. This will trigger an increase in toxin production and kill off the engineered bacteria. The ESA-IR ESA box system in bacteria controls toxin and antitoxin production through ESA-R binding to ESA box, leading to decreased toxin production via AHL-mediated TET-R synthesis and TET-R promoter repression. While within bacteria, MAS-F acts as a toxin, countered by MAS-E as an antitoxin, with their regulation facilitated by J23113 and TET-R promoters, respectively. Hold up, I just realized SAR11 is difficult to obtain. What do we do?
Oh, we can always engineer E. coli as they are easier to obtain. However, because we're using E. coli, our construct will slightly differ from the final construct we utilized in SAR11. But the toxin and antitoxin we use are universal, so we can also apply it to the SAR11 bacteria.
Wait, but how do we know if our engineered bacteria will be able to survive in the wild? Will it be able to co-culture with our probiotic solution and other bacterium in the coral holobiome?
Don't worry, we developed a co-culture model to gain insights on how the dynamics are between the three parties. In order to ensure that our engineered bacteria will not harm our beloved ocean, we created a biosafety model that helped us simulate and understand how our AHL quorum-sensing molecules, SAR11 bacteria, and MAS-F toxin will interact with each other and the dynamics of them. Under conditions of high starting population density, the toxin population decreases to allow the bacteria to grow to its carrying capacity. On the other hand, under condition of low starting population density, which will happen when the bacteria escapes from its intended place of delivery on corals, the toxin concentration increases to kill off the escaped bacteria. We, the research center, have designed to engineer the SAR11 bacteria that is a common food source for corals to produce biofilm that can help attach probiotic to the coral mucus. By utilizing the SAR11 bacteria, we can prevent the coral mucus from regenerating and rejecting our bacteria. Our engineered bacteria can increase probiotic retention and provide enough time for the probiotic to integrate into the coral holobiome, thus providing our coral with beneficial properties of probiotic. We also utilize quorum sensing for biosafety and to prevent excess biofilm production.
I guess we're all set. But just who will deliver our product under the sea?
Hey, we have an order for you to deliver, but I'm not quite sure how you're gonna get there though. It's kind of coral under the seas.
We designed something just for this. Our autonomous underwater vehicle, Delivery, is built to navigate through the ocean. Delivery delivers probiotics through a pneumatic spray mechanism that includes a solution of both our probiotics and our engineered bacteria.
Oh, I see. That's so cool. But how would these hardware be implemented into the real world though?
Well, we have Coral Eats, a coral feed that provides a simple probiotic solution that includes both the probiotics and engineered bacteria that produces the bioadhesive biofilms. The product would be in the form of a probiotic spray in order to be applicable across corals of all different shapes and sizes. Users can decide how they want to use the coral feed, either applying it themselves or by utilizing our hardware that is designed to help the delivery of the coral feed.
I see. So how do you make sure that your service is adapted to all types of corals?
Don't worry, we got you. We will also be providing a fully customizable coral treating service verified by the Delta Foundation, one of the largest SDG organizations in Taiwan. This service provides consumers such as aquariums, coral reef protection agencies, conservation companies, and all the other groups of people that look over a large area of corals. We will provide a packaged assessment of the consumer's specific needs, including the volume of coral, types of corals, the problem it's facing, and the budget, to develop a corresponding customized probiotic included in the coral feed to specifically target the consumer's needs.
But is such a complicated process really worth the time and effort? To commit so much into delivering one order, surely our delivery drivers get a lot of money out of it.
I believe so. But firstly, we want to look into how valuable corals are. So through our economic model, our team was able to break down corals' values into a few different categories, which assisted us in calculating the total value of corals later on. These categories include recreational value, fisheries, coastal protection, and biodiversity values. By combining these values, our team concluded that corals yield a value of $28.8 million. Furthermore, another part of our economic model is contrasting the two ways to allocate coral conservation fundings, maximizing the preservation of resources and maximizing overall environmental benefits. In order to look deeper into this topic, we created scenarios to assist us in the analysis process. In scenario 1, assuming that all corals are equal in quality, to maximize benefits, all funds should be allocated to one reef. In scenario 2, assuming there's one reef that is better in quality than the other, and we can only provide for one reef, it is better to provide for the better quality reef. However, in scenario 3, assuming the less quality reef has greater potential marginal benefit, we allocate funding to the less qualified reef to maximize overall environmental benefits.
But where will we get all these fundings?
Well, we look into how much society is willing to pay to help these corals out. We surveyed more than 500 people in order to get an answer to our question. How much will people be willing to pay for coral conservations, and which demographic groups will be the most willing to pay for it? We collected data from people from different socio-economic classes and then used the Latin class analysis method, which allows us to identify the groups of people that are more willing to pay than others. We concluded that the people who are most willing to pay are young teenagers, elderlies, high-income individuals, individuals who contribute to coral conservation charities, and highly educated individuals. Seems like being educated is a really important part in one's willingness to pay, but how can we get the society to be more educated?
Well, leave this part up to me. In order to maximize the relationship between the educational level of the population versus the increase in public spending on coral preservations that you talked about, our team has designed and implemented several plans in attempts to educate the public. Specifically, we found that a targeted education on coral knowledge and synthetic biology would most align with the education that the public would need to understand the importance of corals in our project to fund current coral preservation efforts. We've developed coral preservation efforts and synthetic biology educational materials, such as public lessons to high school and middle school students on the topic of bioart and bioethics, weekly infographics on the world issues, informational articles with non-governmental organizations on coral-related subjects, and online interview with national magazine organizations that introduces our project to a wider audience. Recognizing our target audience of the youth populations, we sought to inspire them through a video series introducing global youth efforts in solving large-scale problems from climate change to ocean pollution. In addition, we made these resources and learning opportunities available online across numerous social media platforms such as Instagram and YouTube.
Wow, that's some good work you've been able to do!
I know, right? We the best duo!
Hold up! Order your food on Care All Eats today. I mean, who needs other delivery lines when you have us? By ordering your food on Care All Eats, you'll receive a fast and efficient probiotic delivery compared to all the other delivery lines, and also an environmental friendly and sustainable one. Our models can prove that we are the best. At the same time, our delivery rate will support us in delivering our product, Biofilm with probiotics, to our coral customers. Lastly, our relationship with the other vendors and organizations will help us attract attention to the delivery line, making us the best delivery line all over the city. Saving corals is not about just saving one species. Saving corals is about saving an ecosystem. Don't you want to be Aquaman and cure our reef with us? This is Care All Eats, brought to you by Cure All Reefs. Enjoy our